Assuming you've gotten your IDE of choice up and running, let's jump into our first program, which, following convention, will be the Hello World program. The purpose of this exercise is to familiarize you with writing code, running your compiler, and experiencing the build process. So open up your IDE, and if you haven't done so already, create a source file named main.cpp and open it in your editor. At the top of the file, type in the following code. We start by writing #include IOStream. The pound or hash symbol indicates that what follows on that line is a preprocessor directive. The preprocessor is run before the compiler every time you compile, and handles such things as source file or conditional inclusions and macro definitions. If you don't know what those are, it's okay for now. It'll sink in as you use this stuff over and over. The include portion of the statement tells the preprocessor to find code from a certain external file and include it here. Inside the angle brackets is the name of the file you are including. This line tells the compiler, or rather the preprocessor, to fetch the code from IOStream so we can use it here. IOStream is simply the name of a header file that has some basic input and output tools we're going to be using. Don't confuse it with iostream.h, which is a deprecated header that you don't need to use ever. In order to use anything from the standard namespace, we need to tell our compiler to do so. So write using namespace std. std is the abbreviation for standard and is used to refer to the standard namespace. A namespace is basically a scope. Namespaces are used to group items together and to prevent naming conflicts within your program. Don't bother scratching this down in your notebook or anything, as you will learn in great depth about scope in future videos. For now, all you need to know is that this line tells the compiler you're going to be referring to items that are part of the standard namespace. Next, we declare main. This is where your program actually starts when it is run. Every C++ program has a main function. In between the opening and closing curly braces is where the code for your program goes. For now, we'll not worry about the details of function declarations, which will be covered in more detail in a later video. Now, type the following code inside main. The first part of this statement is cout, which is an object from IOStream that handles basic output. When you use cout, you are printing output to the console screen. Cout is then followed by two less than symbols, which in C++ are considered to be a single symbol. In this context, we call this symbol the insertion operator, because we're using it to insert text to the output stream. The insertion operator is then followed by a pair of double quotes surrounding some text. Double quotes indicate to cout that you're passing it a string, which is a series of characters, and cout will print that string to the console screen. Keep in mind that the term print here is used to mean output, not necessarily print ink to a sheet of paper. After the closing double quote, you then write a semicolon. The semicolon is to C++ what the period is in plain English. A period signifies the end of a sentence, and in C++, a semicolon signifies the end of a statement. Almost every statement in C++ must be terminated by a semicolon, and forgetting semicolons is one of the most common syntax errors you'll run into when trying to compile. You might think we're done here, but there is just one more thing. You may have seen code that declares main to be void. This is incorrect. To quote Bjarne Stroustrup, void main is not and never has been C++, nor has it even been C. The standard is for main to return an int. Therefore, at the end of main, we will write return 0. By returning 0, we tell our operating system that the program terminated correctly. And voila! We have written our first C++ program. Now let's compile and see what it looks like. If you're using Visual Studio 2013 with me, you can press F5 or click the little green play button to see your program run. Did you see it? In all likelihood, what you saw was a quick flash of the console screen before it disappeared. This is because all your program does is print a string to the screen and then it ends. All of this can be done by your computer in a fraction of a second. If you want to have time to read the output, you will need to do something to halt the program before it ends. This can be as simple as a statement that waits for user input, but since we're compiling in debug mode, we don't even need to do that. Simply hold Control before you press F5, and when your program runs, it will automatically stop and wait for you to press any key to exit. Try it! If your particular IDE does not have such a feature, you can also add in the following code just before your return statement, and it will halt your program. As a warning, don't get too attached to system commands. When trying to compile, if you got a linker error that looks something like this is the error you will receive if you're trying to use projects with different or inappropriate code generation settings. Here's how to fix that. In the Solution Explorer, right-click on your project and choose Properties. In the left pane, expand Configuration Properties. From that list, expand C++. And from that list, select Code Generation. In the right pane, under the drop-down list for Runtime Library, select Multithreaded Debug or Multithreaded Debug DLL. Also make sure that you are in debug mode by selecting it from the drop-down list next to your Run button. Now you should be able to run your program and see the output. Not the prettiest thing we've ever seen, but it does appear to be working. Let's see if we can at least separate the two sentences. In C++, like the insertion operator, there are a number of symbols that are made up of more than one character, including escape sequences for strings. Let's go over a couple of basic formatting characters and see if we can clean this up a bit. Going back to our program, add the following characters after the letter D, but before the closing double quote. Add a \n. The backslash is commonly used in escape sequences to denote other character values. In this case, the \n is a single character called a new line. When you put a \n into your output string, cout will automatically write a new line to the console screen, so whatever follows will be on the next line down. Let's run this again and see how it looks. Better. In addition to the \n, there are a number of other escape sequences you can use. Here are a few more. Play with them and see what they do. Now you've gotten a hands-on taste of the build process, but let's recap how it goes. After writing your code, when you compile, the preprocessor runs first. Then your compiler runs, producing object files. If you have syntax errors, your code will not compile and your compiler will generate error messages to give you an idea of where you screwed up. Once you have no syntax errors, then your code will compile. Then your linker runs, which magics everything together into a complete program you can run. Now that you've compiled and run your first program, try this exercise on your own from scratch. Create a project named My Project. In that project, create a source file named main.cpp. Write a program that prints out the following string, replacing your name obviously with your name.